Alright. So we are going to take this ALEKS initial knowledge check and we are going to do algebra. So if you guys want to learn how to do this, what algebra should be, let me know. I am recording, so I'd appreciate if you guys monitor your volume and language, please. Alright, so I'm going through algebra. This is what you would see if you were going to retake your initial knowledge check. I'm going to go through it, and you know, I think I did one a couple years ago. I got like an 88, 90%. So this should help you hopefully have an idea of what you should know going into, out of algebra. So a hot air balloon. This table gives increases for 5 time periods. Use the table to answer the question. So this is similar to like a rate of change. We're figuring out how it's changing. It's definitely going up and down. It's not going straight up because we have a negative here, positive, back down, positive, negative. So which period did the balloon move downward the most? Well, from 4 to 5, we went from positive 200 to negative 300. That's like 500. That's more than the other time it went down, which was right here. So during which time period? So it'd be 5. Which period did it move up the most? It's going to be between period 1 and 2 and 3 and 4. Is 227 greater than this? Negative 80 to 121 would be 201. This is 227, so period 4. What did it mean for the balloon to have an increase in altitude of 0 feet? Just like a slope of 0, it's a flat line. It means you're not changing height. So it didn't move. Yes? All right, multiplying. And you could use the calculator, you could not. I'm just going to use the calculator because I know how to multiply. Make sure you put your decimals in the right spot. This should be somewhere in the 4,500 range. And it's 4722 and 48. So 4,722 and 48. If we're talking about money, that'd be dollars and cents. Solve the inequalities. So we've done this a ton. So 48 is greater than 6x. The goal is to get x by itself. Divide both sides by 6. And you get x is less than 8. So x is less than 8. Or you could have wrote 8 is greater than x. That means any number less than 8 would make this true. So this is something that we have not done yet. So let me see if I can get my drawing tools up. It's not. So how can I show you this? Let me pause this recording real quick. All right. So now that we got the tools, I'll show you how to do this. So this is something you would do with multiplication. It's just 2 sets of binomials. So a binomial is just a 2-term expression. I think these drawing tools are going to be janky, but we'll see. I might have to do it like this. So it is going to be C. Oh, got 2 of them. C minus 9 times the quantity C plus 9. What am I doing wrong here? I agree. I agree. Okay, we're going to go to my other option here. So this is something that you'll do some multiplication like this next year, but a lot of it will come in algebra after this. This is so janky. Oh, now it wants. Bro, are you serious? All right, so it's not letting me write with this, but it's writing with this. So c minus 9. I'm using my mouse, so it's going to be ugly. Times c plus 9. So you got to multiply. This is just a distributive property. So you do c times c, and then you c times 9. For the first number, that's going to take care of this. This is binomial multiplication. So c squared plus 9c. Then over here, we got negative 9. We're going to do negative 9 times c, which is negative 9c. And negative 9 times positive 9, which is negative 81. And then we just simplify and combine. You'll notice in this middle part, because you had opposites of this 9, those are going to cancel out. That makes it 0. So the answer is going to be c squared minus 81. Exactly. Oh, so it's not going to let me. Oh, this is so janky, dude. Okay, let's go back to this. You just have to make sure you multiply everything by everything. So we're going to do c squared. That's c times c minus 81. Again, this is showing you stuff that, like, if you knew everything in algebra, this would show you that. So this right here, graph the line. This is not written in y equals mx plus b terms, so I have to make it in y equals mx plus b. So to do that, I add 3x to both sides. I get the y by itself. So 3x plus 3. Now I know my slope is 3, and I know my y-intercept is 3. So then I can just plot my points. Oop, we don't want that. So we got our y-intercept at 0, 3. And then we need to plot more points. So from your y-intercept, you do what slope says. Slope says go up 3 over 1. So 1, 2, 3 to the right 1. 1, 2, 3 to the right 1. You can go backwards too. You can go down 3. 1, 2, 3 to the left 1. Down 2, 3 to the left 1. You only need 2 points to make a line. I like making at least 3. On the ALEKS tool, you just pick 2 points and there's your line. Remember, lines go on forever and ever and ever. So that would be your answer there. Solve the compound inequality. There's a chance I get this wrong because I haven't done this in a while. So compound inequalities are inequalities that have 2 pieces to it. So we're basically going to split it into 2. So it's going to be negative 6 is less than 2x minus 6. And 2x minus 6 is less than 0. So basically, you're just doing what you've always done with inequalities, but this is showing 2. So it's basically saying this is between this and this, compared to one inequality is like, oh, here to this way or here to this way. So we solve, we add 6 on both sides. On this left one, we add 6. And this writing is really, really tough, so I'm going to write as little as possible because it's janky, it's not working. Our internet sucks here. So 0 is less than 2x. Divide by 2. X is going to be greater than 0. So that's one answer. So x has to be greater than 0. Over here, we add 6. So you get 2x is less than 6. Divide by 2 on both sides. You get x is less than 3. So what we're saying is, and this is like a domain on a function, is that x has to be greater than 0 and x has to be less than 3. These are going to be open circles because it's a less than or greater than sign. There's no equal. So you put a circle at 0 and you put a circle at 3. And the question is where is this true? Well, we're saying it has to be greater than 0 and less than 3. So it's in the middle of those two. I call this like a Chinese finger trap. Like it's trapped in between. So that's it. That's all you got to do. Compound inequality. That's not something we talked about. Parabolas. We did not do any graphing of parabolas. A parabola is a U-shaped graph. You get that from functions that are x squared. Normally, algebra, we don't cover this, but you should know what the shape is. You will do a lot of this in Algebra 2. So let's see if I can remember how this works. So whenever you're graphing, something to remember is you can always make a table. Like you can always just make a table and you can say, okay, if I plugged in a number, what would I get? So that is something to always remember because I'm forgetting exactly how to graph this. I think I know in my head, but I'm going to want to get at least 3 points here. Actually, we're going to want to get at least 5 points. It says 5 points. So what you're going to want to do is make a table, and it says 2 points to the left of the vertex, 2 points to the right of the vertex. You have to figure out what the vertex is. Luckily, I remember the vertex is h comma k, and I'll explain what that is in a second. I'm just writing that down so I don't forget. So x comma y, we're going to need 5 points. So to get the vertex, this formula is this. It's y equals x minus h squared plus k. This is the formula, like y equals mx plus b, but for parabolas. And what these things all mean is h is your horizontal shift and k is your vertical shift. K is kind of like the y-intercept, except it's not always on the y-intercept. So when I'm looking at these numbers, I see that we have a k of -1, k of -1, and the h is a -3. Just like with the slope formula, if you plug a negative in, you get a positive. This is really a -3 because you put a -3 minus it, you get a +3. So that means our vertex is at this point here, -3, comma -1. I would have known that as well because the horizontal shift, we're shifting it to the left 3. That's what h represents. We're shifting to the left 3 and down 1. And I know I'm going through this really fast, so if this is like, but like you'll learn this in Algebra 2. So we go left 3, down 1, and that's our vertex. The vertex is like the peak. It's either the peak of the mountain or the bottom of the valley. Think back to when we did functions. We were looking at the stock graphs, and we were talking about the minimums and the maximums. That's what the vertex is. It's the minimum or maximum of this parabola. It's going to make a U. So that's our first point. So if we have our point there, then we can go back to our table and find the rest. So we know that our middle point, our vertex, is going to be at -1, -3. So we need 2 points to the left of this and 2 points to the right. So I'll do -2 and -3, and I'll do 0 and I'll do 1. 2 on the left, 2 on the right. To get the rest of these points, you can just plug in and do the math. So if I put a -2 in this function, I'm going to get, or sorry, a -2 for x, I'm going to get -2 plus 3, right? I'm replacing x. We're going to square that and then -1. And you're just going to replace that x with each of these numbers. So -2 plus 3 is 1. 1 times 1, that's 1 squared, is 1. 1 minus 1 is 0. So we got a point at 0. We have a -3. Hey. So -3, you plug that in, you get -3 plus 3, you get 0. 0 times 0 is 0. 0 minus 1 is -1. We plug in a 0. We get 0 plus 3, which is 3. 3 times 3 is 9. 9 minus 1 is 8. I feel like I did something wrong here. We put in a 1. 1 plus 3 is 4. 4 times 4 is 16. Minus 1 is 15. So yeah, I'm pretty sure I did something wrong here. I feel better about these points on the right. So we get, oh, that's why. I didn't get any other, bruh, I messed up completely. So I know what I did. I was looking at this as the point that I wrote, and I wrote this backwards. So this is not a point. That's wrong. This is really the vertex. That's the point I already have. So I messed up. I got 2 points that are on the right side. I got 0 points that are on the left. That's why it looks funny. So I'll plot those while I have that in mind. So -2, 0. and you'll see this doesn't replicate a straight up and down, and then 0, 8. Now, the cool thing about parabolas is there's a symmetric function. So kind of think of like a butterfly, right? One butterfly wing's the same as the other one. So if you go up on this side, you can count over. So I'll show you that trick here. You notice how right here I'm 1 to the right. If you go 1 to the left, you're going to be right there. Over here, I'm 2 to the left from that point and 8 up. So I'll do the same thing here. 1, 2, 8 up. If I wanted to just plug in numbers and check, I could do the table. But this gets you a parabola. That's what a parabola looks like. So the function that makes this is any x squared function will look like this, or it'll look like this. It could be stretched and squeezed a little bit, but this is a parabola. You will do this in Algebra 2 quite a bit. This is an absolute value inequality. We did not solve those either. You will definitely do this in Algebra 2. You do it the same way, except how does this work? Let me see if I remember how to do it. Otherwise, I might have to ask for help. So I know we do w plus 8 is greater than or equal to 2. And then how do we split it the other way? And then it's going to be w. Is it w plus 8 is less than 2? I might be wrong here. Yeah. I think I'm wrong here. I kind of want to Google it so I don't mess it up. And this is why, like I say, math isn't so much about like remembering everything, because I obviously know this, but I don't remember everything. So if you know how to look, you go, oh, quick Google, how do I do this again? Boom. Oh yeah, I did that before. That's what I want you to be able to do. I don't want you to know how to do everything in your brain. I want you to know how to navigate things. How to navigate things when you don't know something. So what am I looking for? Okay. The sign doesn't change. We just make that a negative. That's what I thought. Okay. We come back here. So back here, instead of doing this, it's going to be w plus 8 is less. Yeah, it's less than or equal to negative 2. So then we solve these both. So we get w is greater than or equal to 10, and we get w is less than or equal to negative 10. And I'm not 100% confident in this because I feel like I got my symbols wrong here, but we're going to roll with it because I don't remember. So if you know how to do it, comment down below. Oh, don't tell me we're freezing. So negative 10, stupid equation IO wants to pop up. And then we gotta get our lines. So we're gonna go on the outside and on the outside because that's where less than and less than. So yeah, somebody go look this up and tell me if I did it wrong. I think I did. Oh, buddy, I don't want to do this. Okay, solving systems. So typically we would do systems in a normal year in algebra. A system of equations is just one or more than one equation on the same graph, essentially. So when you have two equations that are graphed, let's say they're two lines, the system is solved where they cross. So if you have a parabola in a line, it's where they cross. If you have two lines, it's where they cross. If they cross, you have a solution. If they don't cross, there's no solution. So for example, the example I like is if you were going to pick between getting two different jobs, and one's going to pay you like a $10,000 signing bonus but pay you $15 an hour, and the other one's going to pay you $3,000 signing bonus but pay you $30 an hour. At some point, one will pay you more than the other one. Obviously, the one that gives you the more money up front is going to be more at first, but the other one's going to eventually pass that up. It's going to start lower, but it's going up higher. So you got to ask yourself, is it worth it to have this? So a lot of things in life you can decide, is it worth for the short term or the long term? So we want to figure out when they are equal. And I'm not confident in my ability to solve this right now either, because it's been a minute since I've done this. So I will set these equal. Like this. I'll set it equal to 0, so I'm going to add these to the other side. So 0 equals x squared plus 11x plus 18. So when you have this is called a quadratic function. I don't know if you guys have ever heard of factoring, but factoring is something that a lot of teachers like to do. So actually I can factor this because I can see the pattern. So you basically need to break it up and ask yourself how it looks. And I can clearly see that if I do a plus 9 and a plus 2, what you do is you look for which two numbers will add up to the middle number and multiply to this number. Which two numbers will add up to the middle term and multiply to the second term. And 9 plus 2 adds up to 11. 9 times 2 multiplies to 18. There's also something called the quadratic formula that always works. And I'm teaching you guys so much stuff right now, so it's just take it. The quadratic formula, I sing it to Pop Goes the Weasel. So it's x equals negative b plus or minus square root of b squared minus 4ac all over 2a. You'll hear that at some point in your life. You go, oh yeah, Mr. Yates sung that one day. Quadratic formula, remember that song. But this is the answer. So it's going to be, we have to solve these for 0, so it's going to be x equals negative 9 and x equals negative 2. And what that tells you, we're talking about parabolas, right? So this graph will look something, oh, what is going on? This graph will look something like this. There's a parabola, and there is a line, and this is saying that they cross twice, I think. No, that's not what I did at all. I just did the completely wrong thing. So I found the x-intercepts, and these x-intercepts, I don't think tell me anything. So I just did a whole lot of math for nothing. If I had Desmos, I could solve this instantly. How do I want to do this? I don't really feel like messing with this longer than I have to. What if I plug in negative 2? Yeah, I should have known I was doing this wrong because I got two x's here, and I need an x and a y. I need the point where this crosses. So just because I want to see the answer, we'll take a look. So you have access to graphing technology. All you gotta do is graph the two functions. So y equals x squared. Oh, my face. We don't want my face. Y equals x squared plus 7x minus 3. So I recommend Desmos for everybody. If you ever need to graph something, just open up Desmos. There's an app for it on your phone. It'll show you what the graph's supposed to look like. And then the other function was y equals negative 4. So this is going to be a line. All right, so you see these 2 points right here? Hey, I did do it right. Look at that. I just didn't plug them in. So you see the x values are negative 9 and negative 2. So then you plug those into the function, and it tells you where they touch. So where those two lines touch is the solution to this system, the parabola and the linear. So I did it right. I just didn't finish it. So it's negative 9, 15. And there's two answers here, so you have to do or. And if all I had to do was plug in that number, the negative 9, and then plug in the negative 2, you get 13. So that is a quick, brief intro to systems. We did not touch systems. You will do systems in Algebra 2. A system is just two graphs together, two equations together. And those are the points where they meet. Woo! Okay, I love teaching this. They took this out of the freshman curriculum a long time ago. You'll do it in Algebra 2 as well. This is exponent properties. You'll need them for various things. Yeah. So what you'll do here, and this is going to be a mess. I like doing these personally. I think they're kind of fun because they make sense to my brain. but what you're going to kind of do is you're going to apply essentially the distributive property here. So what this is going to tell you is take this 4 and you're going to raise every single thing to the 4th power. And again, this is all exponents, so you might have no idea what I'm doing here, and that's okay. But exponent properties are a thing. So 2 to the 4th power, 2 times 2 times 2 times 2, 4, 8, 16. So 16, and then here it's already raised to the 3rd, so you multiply by 4 and you get 12. And then 3 to the 4th, 3 times 3 is 9, times 3 is 27, times 3 is 81. 8 to the 2nd to the 4th is 8 to the 8th because you're multiplying those exponents, and then b squared, same thing. Now you only want one of each letter in your final answer, and you want to simplify whatever you can. So looking at this, we got 12 a's up top and 8 a's in the bottom. It's just like adding and subtracting at this point. Subtraction, the division property, you subtract. We subtract, there's only 4 left on the top, so this is going to be your answer. A to the 4th, 81, b to the 8th. So this is exponent properties. I actually have some pretty good videos of this on my channel when I used to teach this for freshmen. So if you want to check this out, look for my exponent property videos. B1, b to the 8th. It gets confusing because there's a lot of stuff, but I personally really like those. So why do we keep solving inequalities, dude? Over it. All right, distribute first, right? So we get 3x minus 35 less than, or sorry, greater than. You multiply that negative 2 out, so you get negative 10 plus 8x. Subtract 3x on both sides, add 10 to both sides, you get negative 25 greater than 5x. Divide by 5 on both sides, you get negative 5 is greater than x, which is x is less than negative 5. So hopefully, I know I'm doing this fast, but hopefully that's something that you can do pretty easily. We did cover that. Plus 5. Oh, negative 5. Look at me rushing for no reason. Whew. So this is like that one we did before with the multiplication, but this is messier because this includes more exponents. So you're going to take everything over here and you're going to multiply it. So we're going to do 3w times that, 3w times that, 3w times that. So I'll do that math. So 3 times 7 is 21. 1w times w squared is w cubed. So when you start doing volume and stuff in geometry, you kind of got to know this. 3w times negative 4w is negative 12w squared. 3w times 6 is 18w. We're going to combine here. We're going to do it again with the other number now. So this is like if we were in a non-COVID year and we got through everything, we probably would have done a little bit of everything you've seen so far. Not really this, but I like to still show it when I can. So negative 5 times that, negative 5 times that. That's a plus now. Then you combine like terms and you get your final answer. So I'll just type that so I can save myself some time. 21w to the 3rd power, and then we got 2w squared, you can see. So that's going to be negative 47w squared. And then we got 2 w's, so we're going to go 38w. And we got a single negative 30. So that should be the answer. You combine all the terms that match up and then add them together. Did any of you guys do that on ALEKS this year? Okay, so this is talking about quadratics again. Remember, quadratics will always make a parabola, and you know it's a quadratic because it has an exponent of 2 in it. So this is the formula right in the form specified. I'm not gonna do that. I'm gonna press I don't know. You would have to convert it, and you would convert from this form to that form, vertex form to standard to vertex. It's not that hard. I just don't want to do it right now. We're gonna press I don't know. Okay. So this is more exponent properties. when you multiply, you really add. So it's really going to be v to the 2/3, and this is weird with the fractions, plus 1/2. So you have to remember your fraction rules here, right? You cannot add fractions unless they're the same denominator. So we have to find the least common denominator. So this is covering literally all. This is why I love algebra, because it covers so much stuff. So we need these to be in the denominator of 6. So we multiply this one by 2, and you get 4/6. And you multiply this one by 3, and you get 3/6. And then you add that together, and you get 7/6, right? You don't combine the denominators or anything. So you get v to the 7/6 power. So that was cool. That combined, yep, that combined a bunch of stuff. So this is something you guys have done. This is point slope form. You should recognize this, hopefully, right? Y minus y1 equals m times x minus x1. So this should be something that you guys can do. The point on the line, so you look at the x and the y, and we know it's a -5 and a -1 because it's y minus y1 and x minus x1. So because there's a plus sign there, you know that the x's are actually negative. So this is -5 and -4, and the slope is right there. It's -3/2. That's something that should stick, hopefully. Oh, why do we keep having these? So this is a positive quadratic, so it's going to have a minimum function. The value is at the vertex. You'd have to divide by 2. And then I don't know. I can't remember. Something about getting you'd have to find the vertex. So factoring it and plugging it in will get you the vertex. Ooh, this is fun. Let's see if I can't remember how to do this off the top of my head, but basically a geometric sequence. We did sequences a little bit at the beginning of the year. Geometric sequences go up exponentially, so it's like 4 to the how does this work? X 1/2, I think, something like that. I'm just gonna press. I don't know because I want to teach you guys wrong. But then you just plug it in. So there's a formula and it involves like this epsilon thing, and it'll be like find x or n equals 9. It's a whole lot of fun. I just don't remember. That's algebra 2. Actually, I don't even know if they teach that in algebra 2 here anymore. No, I did it when I was at Reagan, student teaching. We can do this. So this is linear, right? You see a line. A candle is a linear function because you can actually do this. You could graph how long a candle would burn. So you could do this as like a project if you wanted to. After 15 hours of burning, the candle has a height of 28.5 centimeters. After 32 hours of burning, its height is 26.8. What is the height after 22? So what you got to do here is you have to figure out the slope. And this is slope formula. That's all this is. So what you would do is you would recognize that the first one says 15, right? Time is our x, and height is 28.5. So this is our point 1. And then the point 2 would be 32 and 26.8. So it's clearly going down, right? If it went up, that'd be kind of weird because candles don't work like that. So what you got to do is figure out how much did it change in this time. That gets you slope, so slope formula, right? So we do 28.5 minus 26.8, and that's going to be 1.7. And then we do 32. Wait, I said 28.5 minus, okay, so we got to go the other way. So we'll do 15 minus 32, which is -17. And you can clearly see some symmetry there, right? So we divide that, and that's going to be like 1/10, I think. So calculator, 1.7 divided by 17, 0.1. -0.1. So the slope is -0.1. That means 0.1 centimeters, your candle goes down every hour. I wonder if that's real. You guys have a candle and some time. Go do some measurements. So -0.1 centimeters is your slope. Okay, so this is an exponent problem. Same logic applies. You're going to divide a whole bunch of stuff. These negative exponent properties, I call it the J. Cole property. You got to flip it like reciprocals. So the negative exponents can actually go to the top. So I'm going to do 6 divided by 18, which puts a 3 at the bottom. And a 1 at the top. You don't have to write the 1 though. a to the 7th on top, negative 8 on the bottom. You flip those 8 to the top. Now you have 15 up top, so it's going to be a to the 15th power. B, we got 4 on the top, negative 6 on the bottom. You flip it like reciprocals. Those 6 come up. You got a b to the 10th. And the c negative 3rd, we don't have anything on the bottom, so you have to flip it like reciprocals and bring it down. So then the c to the 3rd is in the denominator. J-Cole property. I'm trying to finish this before you guys get out of here. The sum of two numbers is 41, and the difference is 17. What is the difference? What are the numbers? Let's see. 30 and 11 is close. 29 and 18. Wait, 29 and 12. 29 and 12. If you add them up, you get 41. Subtract them, you get 17. That's just being good at math. There's also formulas to do that if you need it. This is inverse functions. We have not talked about any of this. This is composition of functions. We also haven't talked about this, so I'm just going to press I don't know. But you can see, like, if you were to take like a college test and they expected that you knew algebra, they would expect that you know all this. Exponential function. I forgot how to do those, but it's something like e to the, I don't know, 3rd maybe? I don't know. I think that's wrong. I'm just going to move. What's up with all these quadratics? I ain't doing it. Although I could do this one pretty easily. I ain't doing it. So this is a geometric sequence. We talked about this before. So you would just plug in. So you could put in 1. You get 1 to the minus 1, which is 0. 0 times to the anything is 1. So this would be 2. You put in 2, you get 1. So 4. You get 8. Guys, I am still recording. I'd appreciate the volume down. You put in a 3, 2, 16, 32, 4, 3, 16, 64, 128. So this is a system. This is a system of equations. This is exactly what we're talking about. Comparing two things. Am I going to buy this from this person or this from this person? So it costs $5,500 up front, $175.25 per each ton. The other one's $50,041 plus additional tons. So basically, there's a certain number of tons where this one's going to be cheaper, right? Because it's a cheaper upfront cost, but a higher per ton cost. Depending on how many you're going to order, though, you might want to go with this one. So you can graph it or you can solve it. You graph it, you find where they're equal, and then you can figure out when it's going to be the same. I'm just going to skip that because we're running out of time. But that's a perfect example of real life systems, especially if you're in the business world. This, you need to know logarithms, and I don't remember how to do logarithms. Factor each grouping. So you'll pull out what you can pull out. So you'll pull a, actually no, this one's going to get broken up. I ain't doing this either. I can do this. So you multiply everything, so you get negative 5x times negative 30x, which is 30x squared. You get negative 5x times negative 5, which is negative 25x. You get 2 times that's negative 12x plus 10. We're combining the middle term and get negative 37x. And we're done there. Let's see what's, I think I'm going to get like a high, like a mid 80s because I skipped a bunch of stuff. So this would be 6/10, so 3/5. This would be 3/5. I think. Boom, what'd I get? Only 73%. Dang, I'm rusty, dog. COVID, learning loss, hit me. I skipped all this stuff. So basically, if you could do what I could do, you know this much of ALEKS. And if you could do this much in ALEKS, you'd be pretty set. So if you have any questions, drop them in the comments. Thanks for watching.